Hello, welcome to this June 2016 Get Started with CyVerse webinar. I'm Jason Williams coming to you from Cold Spring Harbor Laboratory in New York. Welcome. We hope that you'd stay with us the next hour. And during that time, we're going to cover a variety of tutorials that we hope will get you started using CyVerse right away. Before we actually go into some of the details of how to use the CyVerse platform, I want to make you aware of Adobe Connect and some of the features of this room. Beneath the screen here, there's actually a question and answer pod. So I'd appreciate it if you guys send me a hello, and also let me know if you can see and hear me all right. If you have any issues with your connection during the webinar, we'll try to resolve those for you. Additionally, on the other side of the room there are a couple of different things that you may want to be aware of. One at the top, there is a download of the presentation, so essentially a copy of the slides, and also more towards the bottom, there are a collection of some links that you can open at any time if you need help getting to a place that I'm going to direct you to. It may be pretty quick to just go ahead and use those links. So it looks like everybody says that they can hear me and see me okay, which is wonderful. What I also want to tell you is that as you're viewing the video on the screen, if you move your mouse anywhere on the screen, you should get actually it's probably going to be this side, you should get a little menu that allows you to adjust the quality of the screen. So you can make this HD, or if you're on a wireless connection that's not so good, you can also reduce the quality of the bandwidth that's coming across to you. Finally, at the top of the screen, just above, I guess it's on this side, I'm looking, it's hard for me to sort of mirror and I'm looking at myself off the camera. You can actually see a little button with 4 arrows in it, and that will allow you to make the video full screen. So when the video is full screen, then you have the opportunity to go ahead and see a little bit more clearly, especially when I'm doing some of the demos that are on my desktop. Finally, this entire presentation is going to be recorded and posted to YouTube not too long after the presentation. So if there's anything you missed, or if you just want to share it with some of your other colleagues, you have the ability to do that there. So we have about an hour together. We will give you a quick background introduction to the CyVerse project, and then I'll take you through some demos on both uploading and sharing data, as well as doing an analysis in our discovery environment, which is the web platform, one of the interfaces to some of the web tools, and also using cloud compute with Atmosphere. So let me go ahead and start the presentation, give you a little bit of background to the CyVerse project. So CyVerse, as it actually started, has a vision, the entire project, which is transforming science through data-driven discovery. The mission is to design and develop this cyber infrastructure. And we'll talk to you a little bit about what it means, cyber infrastructure. And today is an example of where we're actually training you how to use it. Now, overall, we're a community of more than 30,000 users. And we have petabytes of data and hundreds of publications, courses, and discoveries that people have been able to leverage these platforms and tools with. The project itself started back in 2008 as a project that was in support of the plant science community. The title there was empowering a new plant biology. Now, as we continue and as we evolved, 2013, you could see really we became a cyber infrastructure for life science. And by the time we get to 2016, where we've just undergone a renaming of our brand here, really the idea of CyVerse is to provide data-driven discovery in science in general. So it's a really platform that's open to everybody. We're entirely funded by the National Science Foundation. So that means we're your colleagues and your collaborators. It's a $100 million investment that's freely available to the community. And really, we're also open to international collaboration as well. So people who want to use this all over the world are able to take advantage of what we have to offer. And we do appreciate it when you cite us. So pay attention to that slide when your first publication comes out and let us know, because we enjoy supporting our users. And that's how we also know the impact, one of the ways we know the impact of our work. But I've used that term 2 or 3 times now, cyber infrastructure. So what is it? Cyber infrastructure is nothing that you're not already familiar with. It's data storage, software, high-performance computing, and also people. But when you take all of those and you really organize them into a system that allows you to solve problems of size and scope that otherwise wouldn't be solvable. So these are some practical examples. When you come to CyVerse, you have access to platforms, tools, and data sets. You actually you can store your data and you compute on your data, so it's not limited by what you have at your individual institution. And they're also, we're very interested in training and support, because if the users don't know how to use and access our cyber infrastructure, then they won't be as effective. The other thing that's really important about our name is that CyVerse supports all domains of life science. So whether you're working with plants, microbes, animals, biomedical data, climate data, ecology, CyVerse is a platform that's built for data. So essentially any type of problem you'd like to come to us with, you're able to work on that and use some of the resources and tools. And it also means that as your project evolves, you may be interested in more than just one domain. And so you have the ability to find tools and find resources that's going to allow you to sort of move back and forth within the same platform. Now, this is a quick look at what we call the CyVerse product stack. On the top here are the interfaces that you, as the basic user, is probably going to interact with. So we'll talk in detail today about the Atmosphere Cloud Compute as well as the discovery environment. There are some things that we won't cover, but we can point you to some additional materials about their use. Now, as you go deeper onto the stack, perhaps you're a developer, or perhaps you are a bioinformatician who's interested in using things in a bit more custom way. We have a lot of foundational services. And some of those are just background things that you don't necessarily think of, but you expect them to work. So that's how our data store is one of our foundational services, the APIs, authentication, which keeps your data secure and safe, and search. And at the lowest level are the actual physical hardware. And again, when you come to CyVerse and make use of our tools, we support the hardware, so you don't have to worry about how am I going to actually run this if I don't have access to a particular computer or to enough data storage. But all of that is open source, and it's open to the user to be able to manipulate and consume as it suits their project and their abilities and their interests. Okay, how was CyVerse built? Really, again, just a little bit of history. We knew for quite a while that big data is important in science. And the first year and a half, the project was really about, I like this phrase, community cleverness. It wasn't about that we build something and we expect everyone to use it, but it was a lot of requirements gathering. From that effort, which still continues today in various forms, we understood that genomic data is certainly the big driver of big data in biology. And so when you come to CyVerse, you'll find tools and workflows for everything from reference-guided assembly, ChIP-seq, variant calling, and there's always more that's being added, and in fact, you can add your own tools. But we never believed that genomic data was going to be the only player, and so we have platforms and tools that support working with genomic data, genotypic data, but environmental data, phenotypes as well, because all of those are needed to really do higher level analyses, everything from pathways to evolutionary models, association studies, etc. So these are always shaped by the community, by you telling us what you need. Another important thing about CyVerse is we collaborate. This is just a small selection of some of our collaborators, but really we emphasize is that we're not the solution to every single challenge that you have. We have a lot of tools, but we're very interested in making sure that if there are some tools or data sets that you need access to, that we can make it as easy as possible by being a good collaborator with these and other projects. CyVerse itself is made up out of 4 core institutions: University of Arizona, Texas Advanced Computing Center, is part of UT Austin. Here we are at Cold Spring Harbor Laboratory, and also UNC Wilmington. So it's really a virtual organization. Additionally, CyVerse has taken off, and this is one of the latest examples. There's also CyVerse UK. So some of the institutions funded by BBSRC stood up their own federation, we call it, with CyVerse. And this is something that's possible, everything on the level of an individual user who has some resources they want to combine with what CyVerse offers, to also something like an institution that actually wants to do a bigger scale approach to it. So all of those sort of mixing and matching, that's what sort of the open source capabilities of CyVerse gives you. But all of this emphasizes, I hope, that CyVerse is open to collaboration, and we want to make it as easy for you, the user, to find your place and to be able to go where you need to go without being tied to us. We love you to use us, but we don't want you to be welded to us. Okay, so in that spirit, let me tell you a little bit more about the actual products that we produce, and then we'll be ready for the demos. Okay, as you see in the slides here, we've got a little analogy that I happen to like. You can think of CyVerse as sort of the Lego blocks or the building bricks that you are able to put them together and build what you want. We have built 75, 85, 95% of the things that you want. The workflows are there, but almost always people want to do some things a little bit custom. So you have the opportunity with the different products we have to put things together and craft a solution that's working for you. And if you don't see what you need there, you can always work with us to get that last piece in place. Here are some of the products in a little bit more detail, and then we'll be ready to go into the demo. So the data store, obviously you're going to need to bring your data to CyVerse to work on it, and you have the resources there to share and manage data with your lab, with colleagues, and the community. Every user has a 100 gigabyte allocation. If you need terabytes, that's also available. You just need to request it. The data are automatically backed up, and we've made it really pretty easy, I think, to upload, download, and share those data. The Discovery environment we'll also do an in-depth demo on, and it's a platform that can run almost any bioinformatics application through the web. You can do it without the command line, so if you're not an experienced command line user, while we want to grow you into that, you can certainly do that through a web interface. It's integrated with our data storage and high-performance compute, and you can also add your own applications. For those of you who may be developers, everything is in Docker, so it makes it really fantastic to bring your tools over into the Discovery environment. Atmosphere is our cloud computing solution. If you don't know much about cloud computing, hopefully we'll convince you through the demo that we're going to do there of how it can really help you scale your science. It's a situation where you have access to hundreds of our virtual machine images. You can really customize them, and again, it's integrated with our other resources. The APIs are really of interest to the developers, and you have the ability to mix and match resources. It's a science as a service platform. DNA Subway is a wonderful platform for bringing bioinformatics into the classroom. We have a number of, I would call, classroom-friendly bioinformatics workflows that allow you to teach tools and concepts in biology and bioinformatics using the same tools that researchers use. And it's really great support for anyone who's interested in inquiry-based learning. That's the key to undergraduate biology. In fact, many, probably all the STEM disciplines really excel, and when we are able to teach them from the inquiry-based approach. Finally, BISC is our image analysis management and metadata platform. It supports hundreds of different image formats, everything from microscopy data to geospatial, and it's also another custom platform where you can essentially decide what you'd like to do through a variety of APIs or tool installations. Okay, so that was a pretty 10,000-foot view of what is available within CyVerse. And now we're actually going to get to a couple demos. Let me remind you also that beneath the screen there, at any time you have any questions, please, please, please stop me. I'd love to answer the questions now. That's one of the reasons why we actually try to do this live every single month, not just to sort of go watch this video, but we love to answer any questions if and when they come up. So let's talk first about getting your data into CyVerse, because that's the first place that you could start. Okay. So as I stated before, the CyVerse data store allows you to store up to 100 gigabytes, and if you need more than that, you're absolutely welcome. There's not a strict cutoff. You won't see it saying full, but we'll talk to you if you have a lot of data that you'd like to store. You can store any type of file that's related to your research, and you can move those files seamlessly between different platforms, between Atmosphere, Discovery environment. You can move them. I'll talk about the command line interfaces because you have the ability to automate and transfer, and you can share your files with lab members, collaborators, and communities. There are a couple of ways that you'll want to access the data store. The point and click way, a really easy one that I'm going to show you right now, is called CyberDuck. Then we'll also show you the Discovery environment, which in this case we'll look at it in terms of actually sharing data. I'll also do a quick exploration of how to do this at the command line so that you can see that it's also quite flexible to use it there. All right, in the Discovery environment, well, I'll come back to that in a moment because I'm going to cover this first. So let me talk about CyberDuck first. You can drag and drop. There's no size limit, and it's easy functionality for your desktop. It works like a Dropbox. So it's like a desktop file system. You just can't manage some of the metadata that's accessible through the rest of the system. In the Discovery environment, you can upload and download small files and do some bulk transfers using CyberDuck is the best way for larger transfers. You can also import from URLs. So there's some limitations there, but some advantages, especially for the data sharing and metadata management. And for iCommands, you can really do everything. It's full flexibility. You can script and automate. You can access it from another server. So it's very customizable, but again, it requires some command line experience. So let's go ahead and show you some of these things in action. I encourage you, again, if you're watching this video, to move your mouse up to the top of the video screen, and you can actually make things full screen. It'll be a lot easier to see my desktop. Up here, I'll also try to make some things bigger, but I just want you to have as best a view as you can. Okay, so I'm on the CyVerse homepage, and from the CyVerse homepage, there's a number of resources. If you go ahead, we're going to talk about this first one, the data store, and click on that one. It'll go through some information about it and some frequently asked questions, some of the advantages of it. The one that we're going to talk to first is about CyberDuck, so you can go through and read a little bit about that. But if you go down here, there's a bunch of files that will help you, and I'm just going to click on that first link that will help you manage your data basics. This will take you through all the basics, and the one that we're going to talk about here is called CyberDuck. So what you'll need to do, and you don't have to do this now, is you'll go ahead and access the information about CyberDuck, because you have to download it. And then once you download it, there's a one-time configuration that you need to do. So it literally takes just a few moments. You'll go and download it. It's available for Windows and also for Mac. And once you download it, and the link is here, installing CyberDuck, you're also going to download one more thing, which is called your connection profile. And you'll have to enter a few pieces of information, including your iPlant or your CyVerse username and credentials. Now, I already have CyberDuck started, so I wanted to show you. It's going to take me a moment to connect. So this is what CyberDuck looks like when it's configured. And again, you might want to make this full screen. I'm just going to double click on my bookmark. And in my experience, it takes about 20 or 30 seconds to actually make the connection to the CyVerse data store. Once it is connected, it's connected. So again, there's going to be a one-time setup the first time you download it to sort of get this bookmark in place. You want to, again, pay attention to the documentation, because on the documentation, it gives you a little bit of information of the things that you need to fill in and some settings you need to adjust. But once you do that, that's basically it. So it should be up and running within 5 minutes. Okay, mine is connecting, so I'm just going to give it a few more seconds, and it should connect to the data store. And then once it is connected, it's essentially like a Dropbox functionality where you can move files between your local computer and the CyVerse data store merely by dragging and dropping them. And you get a record and a history of your transfers. You can see them in progress, especially for large transfers. If things are interrupted, you'd be able to do that. I would also encourage you, when you're doing these transfers, especially if they are large, to make sure you're doing that from a wired internet connection. What we would expect, and this I sort of glanced over a little bit earlier, but what we'd expect in terms of the, back here in this data store documentation while I'm waiting, what we'd expect in terms of the speed of the transfer, and you can go in there, is something about 100 gigabytes moving in about 30 minutes. So you really should be able to get a high throughput connection, but it depends on your local system. Okay, my CyberDuck has connected to my data store, and these are all the files that are in my data store. If I want to move those data, let's say from my CyVerse data store into my desktop, I really just drag it over, and it will take a moment, and then it will start moving the file. Okay, if I wanted to create a file, I'll just do that on my desktop. Okay, on my desktop, I've created just a sort of an empty file, and if I want to move that into my CyVerse data store, it's the same thing. I drag it over, and in a few moments that will start. Now, when you have these elements here, it takes a few seconds for the request to be processed, and then it will go ahead and just start the transfer pretty quickly, and it will go through, and you should see that it's successful. Okay, that's really all that there is to show you about CyberDuck. You're going to download CyberDuck, download the connection profile, and set it up according to the instructions. Within 5 minutes, you should be able to bring your files back and forth just by dragging and dropping. Okay, there's one more thing I'm going to show you before I go to the discovery environment. I'm now going to go to the command line. I'll come back to the discovery environment since we're going to end up there anyway to do some analysis with this data. Okay, if you go back to the home page there when it's talking about the data store, and that link, remember at the bottom, Manage Your Data Basics, it took you to this page. And on this page, there is something there called iCommands. So iCommands is here, and it gives you some of the advantages of it. You're going to go and click and get the documentation for iCommands. iCommands is available for Linux and for Mac. So you can go ahead and download those. In fact, it says there's a new version that was just posted a little while ago, so you may want to go ahead, even if you downloaded this previously, and download those commands. Now, once you download those commands, again, we're assuming a little bit of familiarity with the Linux. Just follow those instructions to set it up. I've already installed it, but you're just going to have to enter this preliminary information. Again, it's a one-time configuration. Let me go ahead on my computer and just show you how it looks. Let me start a shell or a terminal that's a little bit easier to see and make that slightly bigger. Okay, so in order to view it, I would go ahead and initiate IINIT. It'll ask me for my CyVerse password. Okay, and then essentially it gave me no error, so that means that I'm inside. And many of the iCommands resemble Linux commands, and those are in the documentation. So if I want to see the contents of my data store, I can do not just an ls, but an ILS, and it will go ahead and list the contents of my data store. If I want to pull down a file, let's say I want to bring down that folder of VCFs to my desktop, then I can do an iget -r because I want to bring down an entire directory. I want to see the progress. I want it to be verbose. I want to give me a timing option, and IRPVT, these are again in documentation, VCFs, and I want to do that to my desktop. Hit enter, and it will go ahead and bring those files down. And then on the desktop already is my VCF folders that I've downloaded there. An IPut command would also, well, if I wanted to, for example, I could do IPut -F to force it, desktop, /test.temp. I have to force that one since I've already downloaded it or uploaded it. And I didn't ask it to show me. I could do that again with progress just to prove you it happened. Okay, it'll overwrite it, but it'll at least give me, the idea that that happened. So it's really straightforward if you are familiar with the command line, okay? All right, so let me show you the final way that we're going to talk about moving data back and forth. I'll close CyberDuck for the moment and move those files off to the side. The final way that we're going to work with data is through the discovery environment. And actually, you can link to it already from here, but I'm just going to go back to the CyVerse homepage. And on the CyVerse homepage, there is the discovery environment. And there is a link there called Launch the DE, so I'm going to go ahead. It's at the bottom there. And there's also probably a link in the Adobe Connect as well room. Okay, so let me just go ahead and log in. I enter my CyVerse username and credentials. And give it a moment to connect. Okay. So this is the discovery environment. It has a number of features which I'm going to get to in depth in just a moment. But for right now, let's just concern ourselves with finishing our understanding of how data works. If I go ahead and click on data, it's going to open a window. And the metaphor for the discovery environment, it's kind of like a virtual desktop. So it operates on the principles of Windows. You can drag and drop things. So a lot of the things that you'd expect to function, it's pretty intuitive. So if I click on my username, that's actually where my home directory is in the data store. And everything you've been seeing, first through CyberDuck, and then next through iCommands, and now finally in the discovery environment, you can actually see here. So I'm giving that a moment to load. And here are all the files that I just saw a little while ago. If I wanted to download those for smaller files, I could go ahead and click on the file and click on download and do a simple download. Again, for larger files, I wouldn't recommend using anything other than either CyberDuck or the iCommands, because those are operating on much faster protocols than a web HTTP or even an FTP protocol would work. Upload is there, including importing from a URL. Okay? But what I want to focus on now is actually sharing data. And there's two really quick ways that I want to show you to share data within the discovery environment. The first way to share data works only for individual files, so I cannot share a folder. But if I want to share a file, so I have this file called rosids.txt, I could go up to the Share menu and say Create Public Link. When I do that, I'm going to click here on the file I want to create a link for, and then click Create, and it's actually going to create a URL. And if, again, to borrow from Dropbox, which a lot of people are familiar with, this URL is a URL that you can give to anybody, and I can go ahead and copy the link. If I go to a web browser and paste in that link, it will open up a dialog asking me if I want to go ahead and download that. So I paste it in the link, I'm giving it a second, and it will ask you if you want to save it or open it or what have you. To go back to the discovery environment, okay, that link is there, and it gives you a little bit of a warning that links are public. So in other words, if you create this link and you give it to somebody else, you have to be sure that you are comfortable with the fact that they might share it with somebody else or post it somewhere. So you don't want to share very sensitive data this way. You also don't want to share very large data files, because if it's very large, there's always a chance that the download gets interrupted and they get frustrated sharing something that's very large. But for small things, little data sets, often I share slides this way. It's a pretty convenient way to make your data accessible. When you don't want that link anymore, or when you confirm that it's been downloaded by whomever it is that you're sharing with, come back and look on my screen. You'll see next to the link there's actually a little bit of an icon there, and I'm just going to click on that delete, and now the link is going to be deleted, and anybody else who wanted to use that, they're going to click again, that link would no longer work. So you could do that once you're done sharing that way. The other way, whoops, I clicked it twice and I got ahead of myself. The other way to share data works both on individual files, but also on folders. And in fact, if you have a large data set, this is the way to do it. So you would click on a folder, and then you can go up to Share and click on Share with Collaborators. Now, this requires that the person who you're sharing with has an actual CyVerse account. But as you saw, CyVerse account is free, and it shouldn't be that much trouble to share it with them, especially that it's basically instant. So if you have a terabyte data set and you want someone else to be able to access on it and access and analyze it, this is really the best way. So all I have to do is I have that selected as I enter the name of the person I want to share it with. As I'm typing in their name, they'll probably be found in the system along with their institution. I click on that one. And then I have the ability to select how I want to share it with them in terms of the permissions. So back on Manage Data, probably if I go here, not that way, it's probably in the data store. You'll find the documentation in a little bit of detail, or I could even search for it, sharing data, permissions. If you are familiar with Linux, then this is second nature to you, but if you're not, I just want to make it explicit. Okay, so when you share data, you have the ability to give people either read, write, or own permission. Read is just like it sounds like. They can read the data, but they can't make any changes. They could also download it. Write means that they can do everything, including up to renaming it. And own means that they can even move it and delete it. So you'd be really careful to share data only with people who you trust at the appropriate permission level. So back here in the discovery environment, If I'm comfortable giving Cornell read access, I'd click Done, and he would get a notification that it's been shared with him. I'm not going to do that for this purposes here, but you get the understanding. You just press Done. Now, if I open this again, and let's say I wanted to review and maybe even retract permission, I'd come back, I'd see that I shared this with Cornell, and I could click that X, and he would no longer have access. He might have already downloaded it, but at least in this case, I've revoked those permissions. So that's it for sharing the data. When data are shared with you, they would appear in the Shared With Me folder, and if you are viewing your Shared With Me folder, you'll view not only the data of the person that you might have shared with, but there are also some other services or data sets that are shared with everybody through iPlant or through CyVerse in this way. Very easy though is actually on the upper right hand side, you would get a notification that something has been shared with you, and then you'd go ahead and just click on that notification. It would navigate you to where those data have been shared with you. Okay. There are a couple of other features that I won't have too much time to really go into, but I encourage you to read a little bit of the documentation and see more. So one of the very exciting capabilities of the discovery environment, of the data management system of CyVerse in general, is the ability to work with metadata. So if you have a folder or a file, you can go ahead and edit metadata for that file. You could either do it individually by individual attributes of value, but often for particular types of data, let's say you're working with some RNA, there are some standards for how you actually describe that along a controlled vocabulary. These might be your metadata. And by applying metadata, you can do a number of things, everything from submit your samples directly through to the sequence read archive of NCBI, to actually making the search. So there is a simple search here at the upper right hand side, but you can also click on and give a search. So if I wanted to search for everything in my data store that has the tag genus and then has the value Dioscorea, and I can click on that search, and then if I have my files really annotated that way, it becomes much more valuable than simply naming your files, file 1 underscore date underscore species underscore time point underscore whatever else, because at a certain point we have too many files that we really can't name them intelligently. This is taking a lot longer only because I happen to be on wireless, but in any case, within a few seconds it will pull up. I think I really only have 1 or 2 things tagged like that. It will pull up the results for that. And in fact, I didn't show it to you here, but you can also click on a particular search, or you can make that search permanent and make it into a folder so that anything in your data store that matches the terms of that search would always be collected in that point. So I'm going to move on to actually doing an analysis. So there's the results of things that were labeled like that. Let's go on to a couple of slides that we have, and then I will go ahead and do an analysis with you. So let me just go and pull up those slides. Okay, so let me get those slides up. Okay, so for the discovery environment, we've already seen it for just a moment, but let me give you a little bit more of an information as to what you can do with it. As I said, it's a platform that can run almost any type of bioinformatics application. It's integrated with our data and high performance computing, and it's extensible, which means you can add your own applications to it. We just covered the data window pretty thoroughly, so I'm going to move on beyond that. In the apps window, you can run the actual bioinformatics applications. You can build some workflows. You can even modify apps or integrate new ones. We only have time today to just show you how to run an app, but once you understand generally how that works, I think you'd be pretty secure in running any of the other applications that exist within the discovery environment. Under analysis, that's where you're actually going to go to see the status of your jobs, find your results, cancel, relaunch jobs, and you also get a job history. Okay, so let's go into the demo. For our demo, we're just going to go ahead and take some unaligned sequence reads in FASTA format and create a multiple alignment for them. So let me go back and just give you an idea of how that works. So I'm in the discovery environment, and let me just go ahead and open up data. And in community data, there are some training data sets in addition to other things that are just shared with everybody in the community. So under there, there is iPlant training, which you can see I favorited. And in there, there's a couple. Let me just go down a folder or two. I'm waiting for it. It's a little bit slow for me today. There we go. DE walkthrough. And in this particular folder, there's just a couple of FASTA files and other things that we use for training examples like this one. Okay, and I want to scroll up. Okay. DE sample plants. So this is just a FASTA file. I didn't go too much into this earlier, but certainly with plain text files, you can open them. You can also have some edit capabilities. Even for larger files, let's say like a FASTQ file that's unzipped, it's a plain text file. You can preview those without those actually crashing your computer somehow. But in this case, this is just a plain text file that we're going to use in our sample analysis of unaligned sequence reads. So I'm going to close that because I don't actually need to have that open for any particular reason. And I'm going to go ahead to Apps. Okay, when I open Apps and make that a little bit bigger, there's a collection right now. It says about 424 public applications. They're filtered or sorted into different logical groupings. I'm going to go ahead and search an app for something called Muscle. So Muscle is a aligner that I can use to align multiple sequence reads. And I think, oh, it wants me to log in. There's been an update, and this is the last time I haven't, or I have to do that anytime there's an update. So give me a second. This will allow me to see some of the HPC apps. So you may have to do this the very first time you log into the discovery environment and look at the app. So it wanted me to do that. Apparently I hadn't done that since the update. And it will reload. And I'll just give it a minute to do that, and we'll go back to searching for Muscle. The discovery environment usually just opens back up to wherever you were last, so you don't lose your place too badly. Okay, let's go ahead and do that search again for Muscle. All right, now there's a couple of different things that match that. I'm interested in this one that I've started off. You can see that a person is integrated, Sheldon in this case. They may or may not have stars, which are a little bit of a community rating. You can favorite apps, and if you click on the little info button, you can actually get a little bit of information on that app. Where did it come from, who integrated it, where's the user manual, a little bit of the tool information like the version, etc. I'm just going to go ahead and close that and click on the app name itself in order to see the app. Okay, and I've moved that other screen out of the way. So all the applications in the discovery environment look roughly like this, where it's sort of, I call an accordion menu. You have to flip through the different elements of it. So we're going to go ahead and call this analysis, give it an underscore webinar demo. And I can say in the comments, this is a demo for the June 2016 webinar. I have a choice of where the results will go, and I'll leave it in analyses. I have to tell it where to pull data from, so I'm going to go back and browse. Now it's going to open up to the last place that I was actually using data for an app, which might be correct. We'll see it in a moment, depending on where it goes. And it'll save me a moment of time of digging up the endpoint. iPlant training. Okay, we want to go through DE walkthrough. Let me go, it's going back to a different place. So I want to go to DE walkthrough this time and DE sample plants. Okay. And this application only has one option here. So I'm going to tell it's DNA sequence, and then I go ahead and click Launch Analysis. When I click Launch Analysis at the top of the screen here, I'm going to get a notification once the analysis has launched successfully. And then I can move over to this analysis window where I'll see a history of all the analyses that I've done and also the status of any current analysis. I also get a notification at the top about what's going on, what's being submitted, and what's happening. So right now my analysis is submitted, but let me give you a chance to look at or talk about some of the other features that are here in the analysis panel. So if I click on an app that I've run previously and I just check it off, I can go up to analyses and I can actually say, let me view the parameters of this analysis. And when I go ahead and click on the parameters, I can see, you know, what were different parameters or options, what were the input files. I could see what were the outputs for that. I can also go up to analyses and view the analysis info. This gives me a little bit of metadata that I don't need to focus on here, but if there are relevant metadata things, this one just is saying this is a job that was done in the DE, that would be present there. If I want to run the analysis again, I could click on relaunch, and it will actually open the app. And the clever thing about it is that it will open the app, and it will also automatically pull in the same options that were used previously. This is important. Let's go to a job that's a little bit more busy than a fast QC job. If I go to relaunch for a top hat job, there might be, you know, half a dozen parameters there, and you don't want to point and click every time you have to redo it if the parameters are going to be the same or largely the same. So the input data that I used last time, all of those different things, the genome that I used, all of those things will be there pre-selected. This is also where you would go to cancel a job. So if you realize that you mistakenly launched something, you'd cancel it. Okay, I'm going to click refresh and see where my job is at. If you have this open while it's working, it may not automatically refresh. I just clicked refresh because I also simultaneously got a little notification. While that was refreshing, I got the notification that it's done. So if I click refresh one more time, I think it's going to tell me that it's completed. And when it does, I can click on the name of that analysis, and it will take me all the way to where the output of that analysis is in my data folder, so I don't have to remember where the results were put. So it's navigating its way, and I'll let it get there, and they'll be able to see those results. So I'll give it a second. And as it loads, I'm going to see the things I'm interested in. So if I click on that, it'll bring open the actual aligned sequences. While that's opening, I'll also remind you that there's a folder there of logs. I won't get into that now, but the logs contain useful diagnostic information, including the shell commands that were used to run that program. Since essentially these are all command line programs running through our web interface. So if you ever need that, either for documentation or for diagnostics, you have a folder of logs that are available to you. That may also be helpful when someone needs to help you diagnose something. You can share the logs with them. I'm getting a question from Dennis. Will the application finish the analysis even if I need to exit CyVerse? Absolutely. Once you click that analysis and you see that it's launched, it will go ahead and continue until it finishes. Okay, and that's the results of that alignment that was done. Okay, all right. All right, so we have time for one last demo, and I'll just remind you again, please go ahead and send me any questions that you may have through the chat at the bottom or through the question and answer pod at the bottom so that I can answer those, so feel free. Okay, so the last set of demos is with another popular product, which is Atmosphere. So let me go ahead and just give us a couple of slides to orient us to that. So Atmosphere is our cloud computing solution. You have hundreds of virtual machine images that you can customize, and it's integrated with our computing and data resources. Now, what is cloud computing? I need to answer that. And let me make an analogy that might help explain it, because there's two important pieces of vocabulary that we need. One is something called an image. What is an image? And one is called an instance. And what is an instance? So I'm going to answer that one. First, I'll talk about what is an image. Imagine that you have a computer and you buy a new one. So you want to take the files from the old computer and put them onto the new computer. So you could take those files off. You could put them onto a hard drive. But there's another type of file that you could create called an image file. And an image file is different than a normal file. It's not a document or photo. It's a complete copy of your hard drive, your configuration, your settings. Now, you know when you buy a new computer, you need to reinstall software, the operating system perhaps. But if you have an image file, you can actually recreate entirely everything down to your desktop, your icons, your preferences. That's what an image file is. So on the new computer, remember, original documents, images, they're just still documents. But an image becomes a complete clone. So when you're talking about an image, you're talking about an operating system, data sets, anything that was on that original system. That's an image. The next piece of information or jargon is instance. Now in the CyVerse cloud, we physically have CPUs, hard drives, memory in the form of RAM, and when you come to us, you're asking for a certain amount of that. So you'll say, I need a hard drive that's this big, or that need this many CPUs, it has to have this much memory. And of course, to run a computer, you also need an operating system, and that's where the image comes in place. So if you have them both together, you have what's called an instance, or what's also known as a virtual machine. And that'll be available to you at an IP address, which you'll need to log in, and I'll show you that in just a moment. When you come to Atmosphere, you can choose an existing image, so there's several hundred of them that you can choose from. And you can have up to a 16-core, 128 gig of RAM machine. The caveat is that, of course, the resources are limited either by the total use. If a lot of people are using it, you may not be able to get the biggest machines, or every individual user has their own finite allocation. And so if you exceed your allocation, you're going to need to request more resources in order to get a larger machine. You can access these through the shell, the terminal, or VNC if those images have a desktop. And you can also share your images with just a few selected users, or you can make them entirely public. There are lots of reasons to use Atmosphere. I can only give you a few here, but if you have software and data sets that basically monopolize your laptop or your desktop, you might move those over to Atmosphere. The discovery environment won't run graphical programs, so if you have something that already has its own graphical interface, you wouldn't run that on top of the discovery environment. You could run that in Atmosphere. You have sudo access with Atmosphere, so you don't have to wait and ask permission to install things. You can simply install them yourself because you're the administrator. It's great for teaching and for the lab. For reproducibility's sake, you can design your virtual machine, and then every time you want to run that analysis, it has the same software, hardware, with the same dependencies already installed. And you can also use this as a way to make your own software and pipelines available to the larger community. So I'm going to give you a demo, which is essentially how to launch and connect. As I said, you can connect if it has a desktop using VNC Viewer. If in Windows, you'll need PuTTY or something similar to SSHin. Mac and Linux, you already have that. Okay, so let me go to Atmosphere, which is open. You can get it from the main homepage, and I'm already there. So this is Atmosphere. When you come to it, you see virtual, a collection of the instances, or images rather, that you can use. I'm going to log in. Okay, when I log in, I'll see what I'm using currently, what I've launched before, and maybe I'll come and say I want to launch a new instance. And let's say that I want to work on RNA-seq, so I might want to ask, well, what are RNA-seq available? What are some RNA-seq images? I'm just going to type in RNA and see what I come up with. And I see there are a couple things that might work with RNA. Let's say I wanted to use Trinitate or RNA-seq, okay, Tuxedo Trinity. So it's got that. I might click on that. And then I'll say, well, let's launch that machine. And then I'll go through the process of, I could rename it. If I have a project, I can save that in a project or create a new project. And then I need to decide the size, and it's got to be something within my allocation. If I go beyond that, I can request more resources. Once I decide how I want to configure it, I just launch the instance, and it'll be ready for me usually in 10 to 15 minutes. Now, let me go back to an instance I launched before this workshop. Once my instance is launched, it appears on a screen along with an IP address. So I go ahead and select that IP address and copy that. If I want to connect to the desktop, I'm going to start the VNC program that I've downloaded, paste that in with the IP address and hit connect. I'll enter my CyVerse credentials. And then I'm connected to the remote computer. So this is a completely virtual machine that's running, and I can do with it anything I would do with a normal computer. I could start an RStudio session, I can look at some test data, I could visualize something with Cytoscape. If I want to log into this with SSH, I could go ahead, SSH, my CyVerse username at that same IP address, hit enter. It's going to ask me if I want to connect to it, enter my password, and now I'm connected. If I want to show that. Okay, and I can do anything that I would normally do on this computer. So it's a really fantastic way to have on-demand computing directly accessible to you. When I come here, and if I actually want to see some details, if I click on that instance, I can see when I launched it. I could see what's the usage. If I want to reboot it, I can do that. If I've made some changes and I want to save those changes so that the next time I launch it, I can go ahead and create a new image of it. So there's a variety of things. If I'm not using it, I might suspend it if I'm just going to come back to it later. And then finally, I might need to terminate the instance because I'm done with it. So I could go ahead and delete that instance there to just get rid of it. And we expect you to do that when you're not using it. Be careful though, because you need to take the data off the instance. So you could go ahead into that instance and use icommands to transfer data off. In fact, when you start an instance, you need to bring your initial data set onto that. It's not automatically connected to your CyVerse data store. But that's essentially it. You can use Atmosphere in that way, and it's really pretty flexible that you can decide you want to launch anything as you need it. So to wrap up here and remind you to please send me any questions because we're at the top of the hour now. Where to go next? We'd encourage you to keep your eye on the homepage of CyVerse, particularly on the Learning Center, which is in the midst of a refresh that'll be coming out shortly, we hope. But in the meantime, there are a variety of getting started guides, tutorials, videos, and documentation. Keep your eye also on upcoming events because we have webinars that are upcoming. There may be workshops, and you can actually request a workshop where we could come to your institution and train with you and your colleagues for a day or two. We also want to give thanks to the executive team across the 3 major centers. And let me show you one last thing on the CyVerse webpage and remind you again, if you have questions, please go ahead and send those now. If I go to the CyVerse homepage, and you come down to the bottom where you search for it, there's also in the Learning Center where you have all of those pieces of information on to getting you started. And the other thing that's there are some FAQs and also especially Ask CyVerse, where you can go and ask questions. In fact, a lot of times questions of things you'd like to do have already been done and you can search for those questions. But if you need to ask a question, you can ask it here and the entire community can rally to the question and potentially give you some support or help. We really love working with our users. Several hundred sign up every month, and we can't meet all of them, but I'd love to meet you in person at a workshop or at a conference. And as on behalf of the entire CyVerse team, we look forward to helping you accomplish your science and your education objectives.